Hi, good morning all. This is Sambasivam, Assistant Professor, SNS College of Technology in the Department of Mechatronics Engineering. In the two previous videos, we have discussed how the basic structure in industrial robots and applications are we are going to discuss about was discussed in the first video. In the second video, we have discussed about the robot workcell layouts, especially about a robot center layout. So in this video, we are moving towards an inline robot workcell layouts. By the name itself shows and the picture shows and give you an clarity about how the inline robot workcell has been carried out. So this is nothing but an example of an car assembly or manufacturing industry, right? So there is a several robots which is placed in particular point. The robots are on a particular position, which is tends to move to work towards on the incoming raw materials. So the first robo will build, the second robo will make the car shield, third robo will fix the car shield, and fourth robot will fix the door, and fifth robot will build those two materials. This is how the robot has been transformed in a function to produce a real-time product. So in this let there are more than two or three robots are located along in a straight path. So the work is organized and the robots are to as robots are tend to perform in specific tasks which they are assembled to do in certain task and then certain limit. So the example for is a welding line or assembly line or fixing line, everything we can able to say. So example for this, the work part is moving from left to right, but the two robots are fixed and constant where it is tend to perform a task and the incoming raw material. This is how this has to be done. So for that there is a different type of transmission lines because the conveyor it is working based on conveyor. So the first one is intermittent transfer, the second one is continuous transfer, and then third one is non-synchronous transfer. So the intermittent transfer is continuous, a step-by-step process. But in continuous transfers, the material, raw material is continuously transfer, but the robot has to pick the particular point to perform a certain task. Then non-synchronous transfer, it is like stepper motor transfer. It can able to move from one place to another place without any transformation of process. So the non-consequence transfers especially used for producing a product without any intermediate changes. So either one product has to be performed, another product has to be performed. So it may skip the particular in between the product in between both two products. So this is how the synchronous transfer has been takes place. By the name itself, as I said, the intermediate transfer item. It is like in start and stop motion. It has to able to perform from one station to another. But it is also synchronous transfer because all the particles are moving in a particular direction without any stoppages. Then it is the main advantage is the fixed location and orientation with respect to robot during the robot wire cycle time. So the example for this is the three robots are fixed. The robot conveyor has to move particularly in one direction. Each part has to be perform a task by these three robots are performing within synchronous transfers. And it also moving on constant speed. The position and orientation with respect to any fixed location can be continuously changing, and in this especially there will be a tracking problem if we say continuous transfer. The moving baseline tracking system and also the robot pallet to the conveyor at same speed, so it makes an tracking system is most difficult part when compared to other ones. Then moving towards non-synchronous transfers, this is like a stop and go manner. So it is power and free system, and this is nothing but power and free system, which means each pod moves around with independent to other pods, as like earlier, right? So when the workstation has finished the working on the power part, the parts are being processed on the line at which same time the others are being transported or located between the stations. So hence the cycle time may varies according to the each working station because the cycle time the work time of your particular robot may changes, or work time of a particular robot will be taken larger than the previous workstation, or the particular work material has to be performed. So based on the performance, the non-synchronous transfer has been working towards each sectors, and also they are independent to move without an contact with an previous material or previous parts. So it has been operated on each individual parts. And the designing and control of robot systems used in power and free method is complicated for continuous transfer methods. So the continuous power has to be fed into a robot, which makes an difficult process. So in order to obtain a free power, the non-signal transfers are making an violation role. So the power must be power must be huge, and the controlling has to be in a different manner. So which always results in irregular intervals of by using a sensor detection but indicate the robots. So this can be rectified by using a work time cycle. So the robot work cycle has been performed an intermediate transfer for non-synchronous one. So the continuous moving also is difficult for them to understand clear transfers. But hope this has been clearly understand how the robot has been performing in by using an intermittent transfer. In the next video, we can able to see how the mobile robot has been carry mobile also driver can how the transfer function has been working in mobile drivers will be discussed in the next video. Till then, bye bye. Signing off by Sambasivam, assistant professor in mechatronics engineering in at SNSCT College of Technology. Thank you all. We will catch up in the next video.